Okay, so today we are covering Module 5, Lesson 19, and I know some of you are probably thinking, wait, I can't see her, where is she? Well, today, because of the lesson we are doing, I needed all the space on the actual screen, so I want you to be able to really pay close attention to what is going on with the problems and how we're working them out. So, let's go ahead and get started. So for Module 5, Lesson 19, we are actually going to be working through the problem set. So if you would like to pause now and get whatever note-taking devices you have so that you can copy this down and sort of make sure you go through this really thoroughly so you understand it, so that when you do the problem set, you can make sure you get it all right. So let's get started. So it says use the read, draw, write process to solve. Problem number 1. Sue ran 9/10 of a mile on Monday and 7/10 of a mile on Tuesday. How many miles did Sue run in the 2 days? Well, I'm going to show you 2 different strategies. So for strategy number 1, we are just going to take 9/10 and we're going to add it to our 7/10. And we know when we add, our denominator stays the same, so we still have 10. But 9 plus 7 becomes 16. And then we can take this, because we know it's an improper fraction, and make it a mixed number fraction. We know that since we have 16, it's greater than 10. And so we take one group of 10 out, and that makes one whole. Our denominator stays the same. And then when we take 1 10 out of 16, we are left with 6 and over 10. So that's the first way you can do it. The second way you can do it is kind of actually my favorite. I don't always use this method, but I definitely like this method a lot more. So we still have 9/10 plus 7/10. Now what we're going to do is that we want to think of this 7/10. So we're kind of breaking this up. We know that we have 9/10, and 9/10 is really close to 10/10 or 1 whole. So what if we just take 1/10 out here and kind of make a little number bond, right? 1/10, and then we have 6/10 left over, right? Well, we can sort of put this together, and then that makes 10/10 or 1 whole, and then we're left with 6/10. Now we change this into 1 whole, and then we have 6 tenths. But the last step we need to do for both of these is that whenever we're adding fractions or doing anything with fractions whatsoever, subtracting, adding, multiplying, dividing, whatever we're doing with them, we always want to make sure that we have the smallest fraction possible. So 6/10, I can reduce this fraction into something smaller. So what we're going to do is we're going to take 6/10 and we're going to see what we can divide it by to get a smaller, or I guess as close to 1 in the numerator, or the smaller number in the denominator, which would make it bigger. So what we're going to do here is we're going to do the same thing, and that will give us something. So what numbers can we divide 6 and 10 by? Well, let's start. We know that the factors of 6 and 10, we're going to try and find the number that will reduce it the most. So we'll start with factors of 6, because that should be easy. We know 1 is a factor, 2 is a factor, 3 is a factor, and 6 is a factor. And for 10, we know that 1's a factor, 2's a factor, 5's a factor, and 10 is a factor. So the one they have in common is 2. So let's divide both sides by 2. So 10 divided by 2 will give us 5, and 6 divided by 2 will give us 3. So we can write this as 1 3/5. And this should be our answer. But we're not really done yet because we really need an answer statement. So go ahead and type in what you think our answer statement should be. Hopefully you just put Sue ran 1 3/5 miles in the 2 days. And that should be it. Alright. So, moving on to problem number 2. It says Mr. Salazar cut his son's birthday cake into 8 equal pieces. Mr. Salazar, Mrs. Salazar, and the birthday boy each ate 1 piece of cake. What fraction of the cake was left? So this is what type of, what math operation we're going to use to solve this problem. Hopefully you said subtraction. So what we're going to do is that we are going to visualize this first with a number line. Ooh, calm down. Alright, I hate when oh my goodness. I hate when my little pen does this. Okay, let's see. Okay, there we go. Alright. Okay. So, 1. Alright. So our first strategy is we're going to use a number line and count back. So, we've got 0 and 1 whole here. Well, we know that the whole is equal to 8 pieces out of 8 pieces, right? So 8 out of 8. This would be 0 out of 8. So now let's go ahead and divide this into 8s. So I'm going to start with 4 8s. And then we're going to split this into 1 8, 2 8s, 3 8s. So this is 1 8, 2 8s, and 3 8s. And again, we're going to do the same thing here. So this is 5 8s, 6 8s, and 7 8s. Alright, so it says, originally, you know, we have 1 whole, right? So we have 1 whole cake. But it says Mr. Salazar, Mrs. Salazar, and the birthday boy each ate 1 piece of cake. So 1 piece of cake for Mr. Salazar, 1 piece of cake for Mrs. Salazar, and finally our birthday boy also gets a cake. So we jump back 3 times, we find that the fraction of the cake that was left over should be 5 8s. So now let's go take a look at our second strategy. Our second strategy is we want to go ahead and subtract this using our standard algorithm. So we have 1 minus 3 8s equals, and then we got to figure this out. So we're going to rewrite this. 1 is 8 8s. We're going to subtract 3 8s. And when we do 8 minus 3, we end up with 5, which is exactly what we ended up with here. Now you may be asking, well, where did we get the 3 8s? Well, we got it because Mr. Salazar, Mrs. Salazar, and the birthday boy each ate 1 piece of cake. So that's 1 out of 8, 2 out of 8, and 3 out of 8. Alright, so now our last strategy we're going to look at real quick is we're going to look at adding them, adding up, basically. So, alright, so for this third strategy, we will be adding up. And so the best way to think about this is, again, to look at a number line. So I'm just going to do a really quick one real quick. So this is 8 8s. This is 0 8s. That's 4 8s. We got 5 8s, 6 8s, 7 8s. And then we have 1 8s, 2 8s, 3 8s. Alright, so now we're going to see, we have the same problem, 1 minus 3 8s, and we're going to count up to see what we would have to add to 3/8 to get to 1. So another way to visualize this, I'm going to draw this out a little bit, is to think about this using a number bond. So we have 1 whole, or 8/8, and we have 3/8 here, and we do not know what this is. So what we're going to do is we're going to basically think about this as 3/8 right here, right? We have to figure out what do we have to do, how many are in between 3/8 and 5/8. So when we count, it's just 1/8, 2/8, 3/8, 4/8, 5/8. So we end up with 5/8. Alright, so our answer should be 5/8. So you see here, there are many different ways that we solve this, 3 different ways, and each method we got 5/8. So when we go to write our answer statement, 5/8 will be our answer. So go ahead and take a second and write your answer statement. So your answer statement should say the fraction of the cake that was left was 5/8. Now that's a very convoluted sort of way to phrase this, but that's literally just taking the answers, the question, and rephrasing it. Now, a smoother way to say it, you could have also said there was 5/8 of the cake left. That would probably be an easier way to say it. But if you were just going verbatim based on what the question says, that would still be right. So I wanted to show you that as well. Alright, moving on. So it says Maria spent 4/7 of her money on a book and saved the rest. What fraction of her money did Maria save? So if we're thinking about this, the first strategy that I want to use that pops to mind is a number bond. So I'm going to say the whole of her money, if she has 1 whole here, it's going to be 7/7, right? So it says she spent 4/7 of her money. We need to figure out what goes in this part of the number bond. So we can write we can solve this in a lot of different ways, but what math operation should we probably be using right off the top of our heads here to solve this problem? Hopefully you said subtraction. So we can go ahead and write this as 1 minus 4/7, and that should equal something right here. So let's rewrite this as 1 as 7/7. We're going to subtract 4/7, and that should give us 7 minus 4, which gives us 3. So this should equal 3/7. Now again, you can think about this on a number line here really quickly. Is this as 1 whole, or 7/7, and this is 0/7 or 0. And so kind of end up here. This would be 3/7 and 4/7. So you got 5 and 6/7. Oops. I'm supposed to do 5. My bad. Alright. Okay. I just got too happy writing 7. 5/7 and 6/7. And then 1/7 and 2/7. 1/7 and 2/7. Okay. Alright, so you think about it, we're here, and we know that we are taking away 4/7. So that's 1, 2, 3, 4/7. So we end up with 3/7. Another way to think about it, again using a number bond, is to go the opposite way. So if you had your number bond again, draw this as quickly as possible. So this is not going to be beautiful. 1 7, 2 7, 3 7, 4 7, 5 6 5 7, 6 7. Okay, so we know that she saved she spent 4 7ths of her money. So we have to figure out how much did she save. Well, that's the rest of this, right? Up to 1 whole. So that's 1 7, 2 7ths, 3 7ths. So this equals 3 7ths. So we know that altogether, whatever method we use, Maria saved 3 7ths of her money. So go ahead and write your answer statement. So hopefully your answer statement looks something like this. Maria saved 3 7ths of her money. All right. Mrs. Jones had 1 4/8 pizzas left after a party. After giving some to Gary, she had 7/8 of a pizza left. What fraction of a pizza did she give Gary? So, let's take a look at this. We have 1 4/8 of pizza left after the party. So after giving some to Gary, so that means she's giving some away, which means we're doing subtraction. She ended up with 7/8 of her pizza left. How much did she give Gary? So we want to know what is X here. So if we think about this with a number line, just go ahead and draw this out. And I'm actually going to draw this with an endpoint at 2 and my other endpoint starting at 0. So I'm going to make 1 halfway between them. And we know that this is using 8 as our denominator. So 1 whole would be equal to 8 eighths. And 2 wholes would be equal to 16 eighths. Or you could put this as 1 and 8 eighths. Either way, it's the same thing. So we're going to go ahead and I'm going to draw this out really quickly. So this is 1, 2, 3. So this is 1 8, 3, 4, 5, 6, 7. This is 1 8. So actually, I'm going to put 9 eighths. And then down here, I'm going to put 1 and 1/8. And then this is 10 eighths, 11 eighths, 12 eighths, 13, 14, 15, 13 eighths, 14 eighths, and 15 eighths. And then I'm going to put 1 and 2 eighths, 1 and 3 eighths, 1 and 4 eighths, 1 and 5 eighths, 1 and 6 eighths, 1 and 7 eighths. Okay. That was a lot. Okay. So we're starting at 1 and 4/8. So that's right here. Or the improper fraction version would be 12/8. We can confirm this by looking at a number bond. So if we have, alright, if we have a number bond and we have 1 and 4/8, we know that 1 whole is equal to 8 eighths, and 4/8 is the other part of this. When we add this together, 8 plus 4 gives us 12 eighths. So, either think about it in the mixed number format or in the improper fraction. I put it both out here for you, so you can do it either way. Alright, so it says minus x, whatever x is, equals 7/8. So we end up over here. So we need to find out how many in between here is, or how much is in between 7/8 and 12/8. So again, we can do this by just simply counting and going 1/8, 2/8, 3/8, 4/8, 5/8. So x has to equal 5/8. Well, we can also count up and double check. So we can say that, well, we started at, we know that we have 7/8 when we left over. Let's count all the way up till what we had beforehand. So that's 1/8, 2/8, 3/8, 4/8, 5/8. So either way, if we count back or count up, we end up with 5/8. Now, let's go ahead and look at it from a purely subtraction standpoint. So we have, I'm just going to go ahead and draw this line here. A little box off. Okay, so we have 1 and 4/8 minus x equals 7/8. Well, we know that when we subtract, we can rearrange the equation in order to get to subtract this is the subhend as the other subhend. So when we switch it, remember we kind of have to do the inverse operation to move it over, and then we're going to move this 7/8 over. So these are going to cross out. These are going to cross out. So our new equation is going to be 1 and 4/8 minus 7/8 is equal to x. So I'm going to change this from a mixed number fraction into an improper fraction. So we know that 8/8 plus 4 gives us 12/8 minus 7/8 equals x. Oops, x. So 12 minus 7 we know gives us 5 out of 8. So x is equal to 8. So you can see here, no matter what way you solve it, you're always going to end up with 5/8 because that is the correct answer. So when we write our answer statement, which you should go ahead and do now. Okay, hopefully your answer statement looks something like this. Mrs. Jones gave Gary 5/8 of her pizza. Alright, very nice. Alright, number 5. A baker had 2 pans of cornbread. He served 1 and 1/4 pans. Excuse me. What fraction of a pan was left? So, the baker has 2. Oh, come on. Let me go ahead and just erase that. Alright, so the baker has 2 pans. He serves 1 and 1/4 pans. What is left over? So in this question, we want to know what is left over. So again, when you're translating this from the English language into math language, you have 2 pans. You are subtracting this because that's how many you gave out. And you want to find how much is left over. So let's go ahead and do this. We know that 2, if our denominator is 4, 2 is going to be 8 out of 4. Now, we have to convert this one as well because it's also in a mixed number format. So, 1 whole is equal to 4/4 plus 1 would equal 5/4. So when we subtract that 8 minus 5, we end up with 3 out of 4. So this is how much the baker should have in left over. So your answer statement, go ahead and write that. And that should be Mr. Baker, or I guess we'll go ahead and say, alright. Excuse me. We'll go ahead and say the baker had 3/4 of a pan left over. Alright. I think this is the last problem for today, so it's pretty quick. Okay, so this problem is problem number 6, and let's go ahead and read it. Marius combined 4/8 gallons of lemonade, 3/8 gallons of cranberry juice, and 6/8 gallons of soda water to make punch for a party. How many gallons of punch did he make in all? So this problem is like directly off the EOG. Like I have seen pretty much I'm pretty sure it was this exact problem. So, and it dealt with like lemonade or something. So you have to make sure you understand this problem, because this is the goal. This is where we want you to end up by the end of this module. So it says Marius combined 4/8 of a gallon, and if he's combining it, that means he's doing what math operation? Hopefully he said addition. So he's adding 3/8 of cranberry juice and 6/8 gallon of soda water. And this is going to be making a punch for a party. So how many gallons do you make in all? So we want to know what is the total. Alright? So let's go ahead and add this. Well, just thinking about the easiest way to add here, I know 4 plus 6 equals 10. So that's going to be 10/8 plus 3/8. That's really easy to do because 10 plus 3 gives us 13/8. And now we want to reduce this fraction, or not reduce it, make it a mixed number fraction, because right now it's improper because it's got more than the denominator, and so we want to make that a mixed number fraction. So it's going to end up being a whole and a part. So how many groups of 8 can we make out of 13? Well, we can make 1. And what's left over? So if we're thinking about this as a number bond, we have 13/8, and we can collect 8/8 out. Once we do that, what's 13 minus 8? Well, that gives us 5/8. So it's going to be 1 whole, because this is equal to 1 whole. So 1 whole and 5/8. Now the question asks, how many gallons of punch did he make in all? So, how many gallons did he make in all? Well, he made 1 5/8 gallons, right? So, let's go ahead and put this in an answer statement. So go ahead and type in your answer statement, and now that you've typed that in, hopefully you said something like, there are 1 5/8 gallons of punch. Or you could say something like, Marius made 1 5/8 gallons of punch. Both of those are correct. Alright, very good. So now hopefully you paid attention and you were able to get this. If you don't, remember there's no excuses. You can always contact Mrs. Simone and I. We will be happy to help you out. So take all of this, go back through your problem set, and try and make sure you understand it and show your work. Alright, have a good rest of your day, and see you for lesson 21.